Hi everyone, today we will be presenting our work Bottom-up, Top-down Detection Transformers for language grounding in images and point clouds. Our task is language grounding. We are given a visual scene and a language utterance like bottle on top of the bathroom vanity. The task is to find all objects mentioned in the utterance. Here, the bottle and the bathroom vanity. Humans use top-down language-directed attention to localize objects that our bottom-up, non-task directed perception may miss. For example, in this image, the clock may not be the most salient object to attract our attention, but the sentence "clock on top of the shelf" suffices to direct our attention to the right place. However, almost all existing language grounding models in 2D and 3D scenes use object proposal bottlenecks. They feed the given scene to a pre-trained object detector to get dense proposals like shown here, and then select one of them as their answer by conditioning on the language. Thus, if the object detector fails, the grounding model is bound to fail. On the 3D domain, all related approaches follow the detect then score pipeline. Even worse, as object detection has been less successful in 3D, popular benchmarks like SR3D and NR3D assume that oracle proposals are given, which is a major assumption. Recently, MData removed the bottleneck of object detection. It directly decodes boxes instead of selecting from a pool of proposals. However, it has to learn how to detect objects from scratch since it does not exploit a detector's bottom-up feedback. Moreover, it was tested solely on the 2D domain and not on 3D. Inspired by MData and aiming to create a model that works both on 2D images as well as 3D point clouds, we introduced Beauty Deter, or bottom-up and top-down Deter. Beauty Deter gets bottom-up feedback by attending to an additional stream of box proposals obtained by a pre-trained detector. At the same time, it uses top-down guidance from the language utterance to attend to the scene and localize the relevant objects. Beauty Deter is not box bottlenecked. It decodes objects with a detection head instead of selecting them from an input box stream. Moreover, Beauty Deter can use object detection data for grounding by forming utterances like couch, person and chair as shown here, and tasking the model to find all instances of couch and chair in the scene, while associating person with not mentioned tokens as there's no person in the scene. Through these innovations, Beauty Deter achieves state-of-the-art performance on 3D language grounding, outperforming all previous methods as well as MData 3D equivalent that we implemented. With minimal changes, our model works both on 3D and 2D, thus disproving previous conjectures that 2D-based grounding models are deficient for 3D language grounding without carefully designed 3D modules.
Let's now dive deeper into the architecture of Beauty Deter. The input to our model is a scene and a text utterance. A pre-trained object detector is used to extract box proposals. Next, the scene, boxes, and utterance are encoded using per modality specific encoders into visual, box, and language tokens respectively. These tokens enter a cross-encoder layer. In this stage, language and visual token cross-attend to each other, and the visual tokens cross-attend to the box tokens. The refined visual tokens are used to initialize object queries, which attend to the different streams and decode boxes and spans. Let's move on to the results. Under all setups and datasets, our model largely outperforms all previous approaches, including an MData 3D equivalent model that we designed. Our ablations indicate that all added components contribute to the performance boost. If we discard visual tokens and instead select a box out of the detector's proposals, we observe a 10.2% performance drop. This underscores the importance of top-down attention to visual tokens. Furthermore, having additional bottom-up feedback from the box stream contributes a 1.1% performance boost for Beauty Deter. Next, co-training with detection prompts offers an absolute gain of 4.2%. We verify that all our innovations are valuable for the 2D domain as well. We evaluate Beauty Deter on 3 benchmarks, achieving comparable performance to MDeter, while converging faster due to architectural optimizations such as deformable attention. Please check out our paper and project page for more information. We are looking forward to see you in our poster session.